Hello everybody, my name is Mr. Bright. I'm the math department head. I'm down in room 225 and I'm going to be creating some videos so that you guys can stay caught up in your class. Now, I know that learning from a video is not as easy as learning from having a teacher in the room, and so we're going to ask you to work a little harder now. It's going to be a little harder, but it is something that you can do. All right? You got to pay attention to the videos. I'll get the videos posted onto YouTube. The files are too big to post onto Edsby, so I'll put them onto YouTube so you can take a look at them and see them. Watch them again if you need to. And then you've got access to teachers that you can ask for help. For example, I'm usually in my room in the mornings and I'm happy to help out. Mr. Bashir is in room 227. He's available every morning. If you have any questions about math or any of your math homework, he is also available to help you out. So take advantage of those resources and we're going to get through this, all right? So at this point, you should have the handout that Ms. Westwood had sitting out for you, which is the complex numbers. So I'm just going to go ahead and get started with that. Okay, so if we're taking a look at this handout, the notes that Ms. Westwood included about imaginary and complex numbers. So you all haven't learned about imaginary numbers before, and I hate that this is what mathematicians call these because it's a terrible name. It freaks everybody out when they say imaginary numbers. Everybody thinks, well, how can they even exist if they're imaginary? It's just that everything else is called real numbers, and so real numbers are just all the numbers on the number line. Everything that we've ever thought of as a number before is a real number. 1, 5, -6, 2/3, square root of 2. Those are all real numbers. So imaginary numbers are different because imaginary numbers have to do with the square root of a negative number. Now, we can't take the square root of a negative number, right? Not in the math that we have. We don't know how to do it. So what mathematicians did, because we're getting ready to do some math where we're going to have negative numbers inside of radicals. So mathematicians said, okay, let's create this thing, we'll call it I, and it will be equal to the square root of -1. And what that allows us to do is now we can keep working on problems even if we get a negative number inside of a square root. Otherwise, we would just have to stop. We'd say, this doesn't make any sense. There's a negative number inside my square root. But now, we're going to call it I, and it allows us to keep working forward. So in this example, where you've got the square root of -9, what we do is we split it up into 9 times -1. Now that can be rewritten as a square root of 9 times the square root of -1. This expression right here is the same thing as this, right? We can multiply radicals together. So the square root of 9, we know, that's 3. The square root of -1, well, that's just I, right? Because the square root of -1 is I. And so we rewrite this square root of -9 as 3I, okay? So let's just take a look at a couple of examples here. Square root of -2. What we do is we say that is the square root of -1 times the square root of 2. So the square root of -1 is I, and the square root of 2, well, it's just the square root of 2. But now we have a positive number inside of the radical. The square root of -8, same thing. Square root of -1 times the square root of 8. Now, the square root of -1 is just going to become an I. That part's not too hard. But it's the square root of 8 that is an issue. Right? That can be simplified. Now, one way to do that is to think of it as being the square root of 4 times 2. Right? 4 times 2 is 8. Well, when I look at this, I think, well, hey, I know the square root of 4. I can take the square root of that thing, but I can't take the square root of 2. And so this becomes I times 2 times the square root of 2. Yeah, I really should. Let me be a little more careful here. Let's take this down one more step. It becomes I times the square root of 4 times the square root of 2. All right. So the square root of 4 we know. right, this thing is going to become a 2. Here's the I, and here's the square root of 2. Now typically how we'll write this will be 2I square root of 2. All right? So square root of negative 12, right? So take that and write that first step, right, on your own. Break it down to that piece right there. All right, so hopefully you wrote the square root of negative 1 times the square root of 12. All right, so now drop down to this step. Can we break 12 down into two numbers, one of which we know the square root of? Go ahead and write that step. All right, so this square root of negative 1 becomes an I. That square root of 12 I'm going to write as 4 times 3. Now, let's break it down one more step. Let's go to this. So I have I times the square root of 4 times the square root of 3. And I'm going to jump a little ahead, 2I times the square root of 3. Okay? All right, example number 4. Why don't you guys try that on your own? If the substitute could pause the video for just a moment, and everybody do example 4 on your own, please. Okay, so this one wasn't too bad. Square root of negative 1 times the square root of 36. Square root of negative 1 is I. Square root of 36 is 6. Okay, so that's how I works, right? It's pretty straightforward. You just pull the negative 1 out and turn it into an I. The square root of negative 1, let me be clear. You pull the square root of negative 1 out and turn it into an I. Okay, so the next thing we're going to talk about is what it means to be a complex number. So like this up here, 2I square root of 3. Any number that has I as part of it, we call that part imaginary. So that's that BI is the imaginary part. Real numbers, again, that's just what we've always thought of as being numbers before. So a complex number is part real and part imaginary. So an example might be 2 plus 3i. That is a complex number because the 2 is a real number, the 3i is an imaginary number, so together they are considered a complex number. All right? So down here, where you're supposed to write the following in the form of a plus bi, well, we've got that square root of negative 9. So does it make sense? That'll be the square root of negative 1 times the square root of 9, or 3i, right? And then I still have that plus 6 there. However, we don't write it in this order. The I term doesn't come first, it comes second. So I'm just going to rewrite this as 6 plus 3i. And that would be my answer. All right, so if I could ask the substitute to please pause the video. I want you guys to do example number 6, please. All right, let's see how you did. That square root of negative 18 became a square root of negative 1 times square root of 18. The square root of negative 1 became an I. The 18 I broke down into 9 times 2. I know the square root of 9. The square root of 9 is 3. So the I and the 3 are on the outside of the radical, but that 2 got left inside. I still have this minus 7 is right here, but again, the order is wrong. So the minus 7 had to come first, and this is a positive 3i square root of 2, so I put it second with a plus sign in front of it. All right, let's move forward. Turning the page, we are going to learn how to graph complex numbers. And graphing complex numbers is very easy to do. It's just we don't call it the x and the y-axis anymore. We call it the real axis and the imaginary axis. And so when you think about, they use this example of 2 minus 3i, you just treat the 2 the same way you would normally treat an x. You treat the negative 3i the same way that you would normally treat a y, right? If my x was 2, I would go to the right 2. And if my y value was negative 3i, I would go down 1, 2, 3, and that is my point. All right? So to the right 2 and down 3. But it's to the right 2 and it's actually down 3i because it's an imaginary axis. All right? And that's all there is to it. That's how you graph imaginary numbers. So looking at our examples here, go ahead and graph that very first one, that 1 plus I. Let's make sure we're in the same place when we do that. Does it make sense that it would be that red point that I just made? 1 plus I, right? Over 1, up 1. Okay. So again, I'd like to ask the substitute, please pause the video for a minute, and if the rest of you would please plot these points, we'll come back in just a minute and check and see how you did. All right, so the 4i is this blue point right up here, right on the y-axis. What they didn't tell you here is that this is basically 0 plus 4i, right, where the x value is 0. The negative 2 plus 0i is the green one, that's right here. Number 4, 2 minus I, that's the yellow one, it's right over here. And then in purple, there's number 5, negative 1 minus 3i, that is right down here. All right. So now let's talk about adding and subtracting. The adding and subtracting isn't too bad. It's really the same as when you add and subtract real numbers. You can combine like terms. So in this example number 8, the 5 and the negative 2, those are like terms. I can add them together and I get a 3. And then the 7i and the 6i are like terms. They become a 13i, so I get 3 plus 13i. Right? All right. So take just a moment. We don't even have to pause the video. You guys just go ahead and do example number 9 very quickly, please. Okay, so hopefully you got 4 minus 3i, right? The negative 6i and the positive 3i combined to give you a negative 3i. So that's not too bad. Now, subtracting is also, it's just the same. You just have to be careful where people make mistakes on this, and they make them all the time. Do you know where this is going? I bet some of you do. It's the negative sign. They don't distribute the negative sign. You have to distribute this negative sign to both of these terms. I see people forget it all the way through high school. We can rewrite this expression like this. That the coefficient in front of this set of parentheses, there's nothing there, but there is a number there, right? It's a 1. So if you have a 1 in front of your parentheses, then you can just drop the parentheses, and so that becomes 8 plus 3i. I don't need those parentheses because the number in front of the parentheses is a 1. But over here, this has it's a negative 1 that's in front of my parentheses, and so I've got to distribute that negative 1. So when I do that, I've got negative 1 times 2, which is, of course, negative 2. And then I've got negative 1 times 4i, and so that is minus 4i. Now, I do what I did before. I combine like terms. The 8 and the negative 2 become a 6. And the 3i minus 4i becomes a minus I, right? So be sure that you distribute the negative sign. All right, so if you'd please pause the video and everybody do example 11, please. Okay, so for example number 11, you distribute the negative sign, you get 7 minus 3 minus 2i. 7 minus 3 combines into a 4. So 4 minus 2i is your final answer. Okay, so pretty much everything we've covered so far has been pretty straightforward. I know it all looks a little bit different, but it's not too bad. I think what I'm going to do, the next two topics we're going to discuss, they're can be confusing. And I think that I want to wait until tomorrow to go over those so that we can really focus on them and make sense out of them. So what I want you to do for your homework today is problems 1 through 7 and 13 through 16. Okay? Get all that done while you're in class, please. And tomorrow we're going to pick this up and we're going to do the part that is a little bit more confusing. So thanks a lot, and I will talk to you tomorrow.